Alright, let's take a look at section 1.5. In this section we want to cover the notation that we're going to use from math for statistics, so math notation. Alright, so since this is a bit of math and a bit of algebra and a bit of computations, we need to all agree to do computations in the same order. So for this class and for any computational use anywhere, we have a specified order. We call this the order of operations. So it could be very familiar for some of us, or very distant for others. So if we all agree to do the computations in this order, we'll all achieve the same answer. So the very first thing we want to do, let me get a better looking one. The very first thing we want to do is anything listed in parentheses. So if we have computations grouped with any sort of grouping item, so maybe absolute value, parentheses, brackets, braces, we're going to do that first. So computations grouped by parentheses or brackets, absolute value, we're going to do those first. Once we do those computations, we're going to follow up with any sort of exponent, so squaring, square rooting, things like that. So I'll just write square. Okay, that's an n. Alright, and then after exponents we're going to do multiplication or division as we read left to right. So from left to right. So this would be if we had a sequence of multiplication and division. We would just start on the left hand side of the expression and do the multiplication and division as we read it left to right. And the same would go for addition. Now I've simplified the list from the book a little bit. You can take a look at that in section 1.5 and get a better understanding of the nuances of each one. But I'm going to do an example, and I hope to illustrate kind of the order of operations and what it all means. So we add or subtract, also left to right. Okay, cool. So we are dealing with data, and a lot of times data is numerical, and so we have maybe a list of values and we want to denote it, and often we're going to use the capital letter X to denote a list, and the way we write a list in math is with the braces. So I'll denote, okay, this is the start of my list, and let's say that I had a list of numbers 1, 5, 7, 11, 15. Okay, so this is the list of values. X denotes the list, and we have, let's see, 1, 2, 3, 4, 5 scores in this list. So X is my list of scores. Okay, and let's say that this is a population. We're going to use capital N to denote the number of scores is 5, and I'll make a note of that. This is for a population score, a list of scores coming from the population, that is the population. And if this was a sample, well, then we would use a lowercase n to denote a sample. Okay, and as we come across this notation from time to time, I always will reiterate that capital N means population, lowercase n means the number of scores from the sample. Alright, so often we want to look at a particular feature of a list of scores. Often we want to look at the sum of the scores. Okay, and we're going to denote the sum with the capital letter, the Greek capital letter for sigma. So this is a Greek uppercase S. Alright, so this symbol is going to represent add up everything in X. And so if I wanted to represent adding up all of these digits, I could write the summation, so add them up, of capital X. Now within context you would see this and know that X corresponds to this list, in which case this just the sum of X corresponds to 1 plus 5 plus 7 plus 11 plus 15. Okay, so if you added all of those up, that means the sum of X. Alright, so I think we should take a look at an example coming from, well, now I don't remember the page. End of chapter end of chapter exercises. Let's take a look at example at our exercise 19. Okay, so 19. Alright, so it says for the following set of scores, find the value of the expression. Okay, and in this case the set of scores x, let's use blue, x is equal to the list, so brace 3, 2, 5, 1, 3. Alright, and so, how many scores are in this? Since I don't really know if it's the population, if this is, for example, if this was a score for homework out of 5, and this was the entire class, then I would use a capital letter N to denote the number of scores. 1, 2, 3, 4, 5. Okay, but if I didn't know that it was the whole class, then I have to use the sample size and lowercase n of 5. Alright, so for the first one, it says, so part A, it says the sum, well, let's just do the sum of x. We're going to insert our own part A. So this would be 3 plus 2 plus 5 plus 1 plus 3. So if you added these up, 3 and 2, 5, 5 and 5, 10, 11, 14. Okay. Now the A actually given, I'll just write it as B. Everything's shifted now 1. If we have the sum of x squared. Now going back to the order of computations, order of operations, this is telling us the very first thing we would do, and I'll maybe write it as the first step, we're going to square each value. Okay? After we squared each value, then we will find the sum. Okay? So in other words, we can make the list for x squared. This would be, well, 3 squared, so the list would be 9, 4, 25, 1, and 9. Okay? And now the sum of all of those would be given as 9 plus 4 plus 25 plus 1 plus 9. So 1 and 9 is 10, 35, 39, 48. Okay, so the notation here is saying, okay, first square the x and then add them all up. Okay, so each one in the x list, square it, then add them up. Okay, let's take a look at the next one. So again, let me write our list x. We have 3, 2, 5, 1, and 3. Okay, so this one, B. Okay, we have in parentheses the sum of x squared. Now, when you write it like this, it says, when the order of operations says, do whatever you have in the parentheses first. So I've denoted that with this set of parentheses here, I've denoted that the summation should happen first. In other words, I can interpret this as 3 plus 2 plus 5 plus 1 plus 3. Whoops, that's a horrible looking 3. Alright, let's go back. Plus 3, and then again, don't want that. And then square everything. So add them up first, then square. So we already know that the sum here, 3, 2, so 5, 10, 11, 14. So this is 14 squared. Okay, which would be, well, let's see, 14 times 14. That would be a 6, carry the 1, 56, 4, 1, so 196. A calculator would probably help that. Alright, let's see part C. It says the sum, and then it sets off a parentheses x minus 1. So this is saying, very first thing it wants you to do is subtract 1 from each x. So in parentheses subtract 1, and denoting x is just saying every value that you see here, subtract 1 from it. So first thing is subtract 1 from each value. So in other words, we have x minus 1. The list is going to be 2, 1, 4, 0, and 2. So subtract 1, and then we're going to add them all up. So we have the sum, x minus 1 is equal to 2 plus 1 plus 4 plus 0 plus 2. So 2 and 2, 4, 5, 9. Okay, now notice in part D it gives you a little bit different expression. It says the sum, this is part D, the sum of, and it denotes parentheses x minus 1 and then squared. So what this is saying, the very first thing we're going to do is subtract 1 from each item. Subtract 1. Okay, then we're going to square each one, each number, and then we're going to add them all up. Okay, so if our list originally, again, let me put x here, we have 3, 2, 5, 1, and 3. Sneak that in there. Then, let's see, in blue, so x minus 1 would be now 2, 1, 4, 0, 2. Then we look at the list squared. This would be 4, 1, 16, 0, 4, each item squared. And then to add them all up is now just to add up every value in that list. So 4 plus 1 plus 16 plus 0 plus 4. So 4 and 16, 21, 4. 21 plus 4 is 25. Okay? So the order in which computations are applied, the order in which we do the computations matter, and when it comes down to it, always just start from the inside and work your way out. Okay? All right.